Hello everyone, Mr. Minnick's my name. Math is my game. Welcome back from a long break. Today's lesson is called TI Topics. This is one of 4 parts. Today in particular we're focusing on linear equations. So TI Topics, linear equations. The whole idea behind this week's lessons are that the lessons should be anywhere between 10 and 20 minutes, let's say. We're going to be looking at 4 different concepts, some of which we've already covered, some of which we haven't covered yet. But regardless, they're all related to the TI-Nspire graphing calculator, okay? If you've never seen the TI-Nspire, well, there it is. I've got mine up and at 'em. Speaking of the calculator, the scratch pad, I see a lot of you using the scratch pad. Don't. The scratch pad's very limited. Don't use it. So let's just dive right into today's lesson. We're going to be talking about lines, and with lines, there's standard form equations. There's standard form linear equations. And standard form linear equations, make sure that's a M at the end of that, standard form linear equations, they look like this. They have a capital AX plus capital BY equals capital C. The interesting thing is that A, B, and C are integers. A, B, and C are integers. A, B, and C are relatively prime. With respect to one another, they're relatively prime, and A has to be positive. If I didn't put those stipulations on it, we could have a lot of different standard form equations that are all equal. For instance, the one I used in my morning class today, 7x plus 14y is equal to 21. Although that looks to be in standard form, our a and our b and our c, they're 7, 14, and 21. Those are integers. A, 7, is positive. But those numbers are not relatively prime. 7, 14, and 21 are all divisible by 7. So if we divided a 7 out, we would have 3x. I'm sorry, not 3x. Where did I get that from? We'd have x plus 2y equals 3. So this equation and this equation are similar. They're equivalent, but in standard form, this bottom one, x plus 2y equals 3, that meets our criterion, okay? So standard form equations are one form that we're going to look at. And another form of equation that we are going to look at is slope-intercept. Slope-intercept. That's the one that everybody on planet Earth knows. Slope-intercept. That's the one everybody knows. That's that y is equal to mx plus b. And we like that because we can quickly identify our slope. We can quickly identify our y-intercept. So that first equation that we see, some things we might want to know are the slope and the y-intercept. So if we take that x plus 2y equals 3, using some algebra, we would subtract x from both sides, and we would get 2y is negative x plus 3. And using a little bit more algebra, we divide by 2 and divide by 2 and divide by 2. So we would end up in slope-intercept form with y equaling something plus 3 divided by 2. And we have negative x over 2. What you don't see is that there's really a 1 sitting right there. So our slope is actually negative 1/2 x plus 2, all right? So those are 2 forms of equations that we're going to be looking at today. And some things we're going to be talking about, some questions we're going to be answering about these are, what's their slope? What's their y-intercept? What's their x-intercept? Okay, so let me be clear about something if I can. When we talk about an x-intercept, by definition, an x-intercept is the value of x when y equals 0. It's the value of x when y equals 0. So if we looked at our last equation in standard form, x plus 2y equals 3, we would replace y with a 0, so we'd have x plus 2 times 0 equals 3. So we'd have x plus 0 equals 3, or x equals 3, or the 0.30. Okay. The interesting thing is, if I back that thing up, if I just go back to the top of this, I know it's the value of x when y is 0. When y is 0, this whole first term goes away, and x is 3. Boom, there it is. That easy. Okay. So x-intercepts are pretty easy to find when something's in standard form. Okay. When an equation is in standard form, an x-intercept is really easy to find. If we had an equation in slope-intercept form, though, something like y equals negative 6x plus 2, let's say, finding the x-intercept to that, probably not as easy. It's the value of y when, I'm sorry, the value of x when y is 0. So 0 equals negative 6x plus 2. So we subtract 2 from both sides. So negative 2 is negative 6x. Don't you dare say the x-intercept here is 3. It's not. This is a different equation than the last one. So we divide by negative 6. So our x-intercept here would be negative 2 divided by negative 6, or 1/3. Okay, the point 1/3, comma 0. So the point is, finding an x-intercept from a standard form equation sometimes is easier than a slope-intercept form equation. Okay. So we'll be talking about x-intercepts, and we're going to be talking about these kinds of lines. I don't know if you remember this. Vertical lines have a slope that's undefined, and x equals some number is how their equation goes. On the other hand, horizontal lines have a slope of 0. Okay, their slope equals 0. This is really a 0 because their slope is 0. Okay. This u means that the slope of of a vertical line is undefined. That's what that u there indicates, all right? So let's quickly graph one of each of these. Suppose we had something like x equals 3 and something else like y equals negative 1. On an xy coordinate plane, here's our y-axis, x-axis, xy. X equals 3, that's going to be a vertical line. X is equal to 3, when all the time. 1, 2, 3. X equals 3, it's going to look like that, right? Maybe over a little bit more, but you get the idea. Y equals negative 1, going to look like that. Right? Vuxoid, vertical and horizontal lines. Sometimes finding their x and y intercepts, or maybe even their slopes. Well, their slopes should be easy, but their x and y intercepts, that's a whole nother can of worms. So we're going to look at 3 examples, and we're going to look at how to do these with and without the calculator. So let's just get right to it. Here we go. Example number 1. We're looking at 3x minus 2y. 3x minus 2y is equal to 6. So first things first, I notice that's in standard form. That's in standard form. What we're going to want to know about this is the slope. We're going to want to know the x-intercept, and we're going to want to know the y-intercept. And I got to be honest with you, 2 of those are real easy to find. The third, not so much. The intercepts. If we think about an x-intercept is the value of x when y is 0, the x-intercept, we could kind of cover that term up. So the x-intercept, 3x would equal 6. Our x-intercept should be 2. Our x-intercept should be 2. Should be. We'll see in a minute. By a similar idea, the y-intercept should be easy to find. The y-intercept's the value of y when x is 0. So I guess we would just be kind of covering up that term. So our y-intercept here would be negative 3, it looks like, right? Negative 3. Negative 3. Okay, so those are pretty easy to find without a calculator. Didn't even touch a calculator yet. Now the slope of this equation The slope of this equation is something that people struggle with. Not many people would give me the right answer for the slope of this. Some people might say it's 3. No, it's not. Some people might say it's 2. No, it's not. The slope's not 3. The slope's not 2. Well, it's -2. No, it's not. And it's not 6 either. You would have to put that thing into slope-intercept form to find the slope. So in other words, you'd have to have -2y is equal to -3x plus 6. You would divide by -2, divide by -2, divide by -2. So you'd end up with y equals positive, negative divided by negative is positive. That's going to be 3/2 x minus 3. So here we see our y-intercept. We call that. And then our slope would be 3/2. Our slope would be 3/2. So the good news is what today's lesson is all about is using the graphing calculator to come up with these things. So I'm going to show you some things. You want to jot some of these down. One is trace graph trace. That's going to be your best friend. Trace graph trace. That's going to be your best friend today. Trace graph trace. Not TMA or TMI. Trace graph trace. Okay, that's going to be a big thing. So let's go to the calculator. I said don't use the scratch pad. Well, how do I not use it? Well, you got to go home. Home, start a new document. Don't save changes to the old one. And we're going to add a graphs page. Now, first thing off the bat, you'll notice the calculator wants f of x equals. If you don't know this, know that f1 of x equals, it's kind of like the calculator saying, I want the equation in the form y equals. That's what the calculator is really saying. It's saying, I don't understand how to enter anything into here unless you put it of the form y equals. And the problem that we've got is our equation isn't in that form. Now, we put it in that form, but if we would like to put this form of the equation in there, we should be able to do that, and we can. We can. What we're going to need to do is we're going to need to go menu. We're going to need to go graph, entry, edit. We're going to need to pick equation. We're going to need to pick line, and then it'll give us some choices there. So menu, graph, entry, edit, equation, and line. We're going to need to go through all that from our graphing page to be able to do this. So it's going to be menu, graph, entry, edit, equation, and line. Okay, that's supposed to say menu, not McNew. So let's take a look. Menu, graph, entry, edit, equation, and line. Oh, so the first order is slope-intercept. Nope. Vertical line. Nope. We want line standard. Remember, we said this is in standard form, so we want standard. And we're plugging in coefficients. Our first coefficient is 3. Our next coefficient, it looks like -2. So we'll plug in a -2. And then the last coefficient is 6, and we'll plug in the 6. And we'll go ahead and press enter, and it graphs the line for us. So maybe you knew that, maybe you didn't. If you didn't, there you go. The graphing calculator is capable of graphing standard form linear equations for you. Also, I told you that your best friend is going to be trace graph trace, because it's going to find x-intercepts, which are the same thing as zeros. X-intercepts and zeros are the same thing. And it's also going to find y-intercepts. So if I go menu, trace, graph trace, whoop, escape. Let's try that again. Menu, trace, graph trace. My cursor is at a particular spot. What I'm going to use is my right and left directional pad. Now, my calculator and my smartboard don't play well, so I'm just going to use my keyboard's toggling. I'm arrowing to the left. Remember an x-intercept? is the value of x when y is 0. So I want the value of x when y is 0. So I'm going to arrow over here. Oh, look at that, 0. An x-intercept, a 0, they're the same thing. It's 2, 0. Let's see how we did. 2, 0. Did we get it? Yeah, we did. There it is, 2, 0. I want the y-intercept. I'm toggling. I'm arrowing to the left with my directional pad. Hey, look at that, the y-intercept. 0, -3. We got that. 0, -3. So here's the one. I said slope. Some people are bad at finding the slope given a standard form equation. Most people are going to write 3 over 2 as 1.5. You know I can't stand decimals. I can't stand decimals. So this next part, keep in mind that if you get a decimal, I want you to change it to a fraction. Please, please change it to a fraction. But the slope, what the slope's going to be, the slope is going to be dy dx. Without getting too complicated into matters, if you ever take calculus, you're going to study curves. And in calculus, they study curves and then they study a line tangent to a curve. So they'll call that line L, and they'll look at the slope. They'll look at the slope of line L. And what that is, it's dy dx. And so dy dx is a fancy way of saying slope. Good thing for us, on the calculator, but if you press menu and you go back to analyze graph, you'll notice, hey, there's a dy dx. The calculator can tell you the slope of a line. Dy dx, and you'll notice the number 1.5 appears. That's the slope. It's asking you for a position. Well, a line has the same slope no matter where you go. If I use my directional pad and I move that, the slope's always going to be 1.5 because for a line, the slope never changes. So regardless, the slope is 1.5. Now keep in mind, I would expect you to write that as 3 over 2. This is varsity math, and we don't like decimals in here. So there's example 1, our x-intercept. Menu, trace, graph trace. That'll find your 0, which is your x-intercept, and also your y-intercept. Pretty easy, huh? It's pretty cool. So hopefully with this, you'll have a better idea of how the calculator operates, and you'll feel a little bit better, more comfortable about using it. So let's look at example 2. There's just 3 examples we're looking at. Example 2 is going to be a special kind of line. We'll look at x equals -1. Again, we're interested in finding the slope. We're interested in finding the x-intercept, and we're interested in finding the y-intercept. So this line is x equals -1. I'm going to go to my calculator. I'm going to go doc, insert a problem, and graphs. I want you to notice that now it's 2.1. That means I'm in the second problem on the first page. I started a new problem. Okay. Again, my calculator is prompting me f1 of x equals, which is like saying y equals. But look at my equation. My equation doesn't even have a y in it. It's x equals -1. So I'm going to need to go back to this menu, graph entry edit, equation, line. And it couldn't be any more clear when I do that. Menu, graph entry edit, equation, line. Look at option 2 right there. It even tells you, hey, x equals some number, that's a vertical line. Let's pick that. X equals what? I think it's -1, right? X equals -1. Enter. There it is. Graphs it for us. Slope, that's the dy dx. Hit menu. Analyze graph, dy dx. Oh, look at that. It's undef. Should have known that. Should have known that, but it is undef because it's a vertical line. Vuxoy. Escape out of that. Menu, trace, graph trace. -1, 0. That's my 0, right? My x-intercept. It's kind of interesting. It doesn't call it a 0 here, but it is the value of x when y is 0, -1, 0. So I wonder about this y-intercept. what my value of y is when x equals 0. Where the graph goes through the y-axis. Here's my y-axis. It appears as though the graph's not going to go through it, and that's right, it's not. Because of that, there is no y-intercept. Now, some people might want to say, no solution. Don't say that, because we're not solving for anything. Some people might want to say it's 0. No, it's not 0. There isn't one. It's not applicable. It's not available. There isn't one. If you want to say it this way, say there ain't one. I don't care how you say it, but there isn't one. There's no y-intercept. There's no y-intercept. Okay? That was our second of 3 examples. This last one, I said I was going to try to keep this to 20 minutes, so here we go. This last example, it's going to be in slope-intercept form. Example 3, y equals negative 0.01x plus 3,000. So we're going to look at our slope, we're going to look at our x-intercept, and we're going to look at our y-intercept. Slope should be easy, negative 0.01, right? That's easy enough to find. Y equals mx plus b. Y-intercept should be easy, right? Y-intercept is 3,000. Remember, the y-intercept is the value of y when x is 0. The x-intercept, that's going to be the tough one on this. Being able to see the graph, that's going to be the tough one on this. Now, this is set up y equals, so when I go to my new problem, doc, insert problem, graphs, when I go to my new problem, it's already set up for y equals, so I don't need to go any of that menu graph entry edit stuff. I'm ready. Negative 0.01x plus 3,000. Let's try that again. I didn't realize nothing was happening. Negative 0.01x plus 3,000. Boom. I don't see it. I don't see it because the graph is translated up 3,000 units. And my window only goes to 6.67. Huh. Guess I better change that. Menu. A window. I better change my window settings. X min and max I'm not going to mess with. But I know that my y-intercept is 3,000. So maybe I want to look a little bit higher than 3,000. Maybe I'll go 3,001 for my y-max. I know my y-intercept's 3,000. Maybe I'll go 29.99 for my y-min. And let's look at it now. Oh, there's the graph. There it is. The graph is falling from left to right. The graph will go through the x-axis at some point. The question is, what is the value of x when y is 0? Oh, we could do that trace thing. Menu. Trace, graph trace. Hey, there's our y-intercept, 0, 3,000. The D-pad, we're going to have to do that a long time. Maybe we could do the slope thing. Menu, analyze graph, dy dx, that's slope. Hey, look, the slope's negative 0.01. We got that. We got that. So how are we going to find that x-intercept on this? We've got f1 of x equals negative 0.01x plus 3,000. We want to know the value of x when y is 0. This is kind of like our y. You could do some algebra and say 0 equals negative 0.01x plus 3,000 and solve that. Or if you've put in that function into the calculator like I have, you could go doc, insert a new page, a calculator page. Notice I'm on 3.2. Now, if you didn't enter this function like I have it entered as F1, this is not going to work. But what I'm going to do is I'm going to end solve. I'm going to end solve f1 of x. That's my equation. I'm going to go ahead and let that y equal 0, and it'll solve for x. I'm going to let that y, f1 of x, I'm going to let that equal 0, and I'm going to solve that for the variable x, and this will give me my x-intercept. There it is. It's 300,000. 300,000. The value of x when y is 0. Now, on my graph, that probably would have taken a minute to find. Probably would have taken a minute to find. Menu, window, zoom. Let me try zooming out. Zoom out from here, zoom out from here, zoom out from here. Zoom out, zoom out, zoom out, zoom out, zoom out, zoom out. I'm zooming out. Oh man. Menu. Zoom, zoom out from here, from here, from here, from here. Oh, okay, there we go. Menu, trace, graph trace. Oh, that's going to take forever. The cursor's not even moving. Anyway, hopefully you get the idea. Hopefully you see that some of the stuff's pretty easy to find by hand. Some of the stuff the calculator makes easier. Hopefully you got to get an idea that the slope, remember, is dy dx. Y-intercept comes from trace graph trace. X-intercept can sometimes come from trace graph trace. And sometimes your viewing window needs to be adjusted. Maybe menu, window, zoom fit. That's not a bad window. That's pretty good. Okay. So it's been real. It's been fun. I hope it's been real fun. I hope it's been educational. And this has been TI Topics Linear Equations. Today's worksheet is due before you pass out. Have a great day. Good.